Okay, we're starting lesson 4.2 today, but we're actually going to break it up into two parts. We'll finish 4.2 tomorrow. Today, the focus is going to be using Pascal's triangle to expand binomials to any power. But before we jump right into how do we make Pascal's triangle, how do we use it to expand binomials, let's just take a look at, well, there's Pascal. All right. Let's take a look at an example of what we would have to do if we did not know anything about Pascal's triangle, like what you may have had to do on the previous assignment, or maybe you did something like this in Algebra 1. Literally, this says to expand this binomial x plus y, when we say raise it to the third power, it's literally like saying multiply it times itself 3 times. And we had a situation similar to this in the homework that we just looked at. We could put two of these together using FOIL. Doesn't matter how you group them. I'm just going to put these first two together. And using FOIL, I would get x squared plus xy plus xy plus y squared. And then we would put these two together in the middle to make 2xy plus y squared. And then the binomial that we have not multiplied yet, we would use that one. We did something like this earlier where we multiplied a binomial times a trinomial. And that involves really the distributive property twice. We would distribute the x to all three of these terms first. X cubed plus 2x squared y plus xy squared. I just multiplied x times each one of these. Now I'm going to go through and do the same thing with y. I'm going to multiply y times each one of these. All right, and now we gather up like terms to come up with a final answer. X cubed plus 3x squared y plus 3xy squared plus y cubed. Boy, it's a lot of work. Well, what if, and this might be possible, this might happen on tonight's homework. Instead of x plus y to the third, there are times when you're going to have to do x plus y to the 9th. Can you imagine? X plus y times itself 9 times and going through this? That would take a long time, and it would lend itself to making some errors because we've got to be very careful all the way through that. Well, that's where Pascal's triangle is going to come into play. It's going to make this so much easier for us to expand any binomial to any power. So first of all, you need to understand how to make it. I'm going to ask you on the quiz and on the test to construct Pascal's triangle. Well, it's really a pretty easy thing to do. Once we learn how to make it, then we'll look at how to use it to expand binomials. So Pascal's triangle always starts off with a single number 1 at the top. Below that, we're going to put 2 number 1s. So I have one number at the top, then I have 2 numbers below that, and now a pattern starts to develop. Every row of the triangle starts and ends with 1. What goes in between is the sum of the 2 numbers above. So 1 plus 1 is 2. So I have 1 number. Now I have 2 numbers. Now I have 3 numbers. The next row should contain 4 numbers. You start with 1. You do 1 plus 2, and that's 3. 2 plus 1, also 3. You end with 1. Every row starts and ends with 1. The next row starts with 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. End with 1. Sarah, can you give me the next row? Awesome. Very good. Kate, can you give me the next row? Well, we got to start with 1. Awesome. Let's do one more. We could do this forever. Colin, give me the next row. 1, 7, 21, 35. That's right. 20 and 15. Okay. Good. Okay. And really, technically, Pascal's triangle never stops. It just continues on and on and on. But what this means for us is these numbers in the triangle represent coefficients of our particular expansion. So let me show you what I mean by that. For this top row of the triangle, it would be used for a binomial that's raised to the 0 power, like any binomial raised to the 0. What is anything to the 0 power? Okay, so that makes sense, right? Anything to the 0 power, if we had a binomial raised to the 0, that would just be 1. So this next row of the triangle would be used if the exponent for the binomial is 1, like x plus y to the first. The next row of the triangle would be used for an exponent 2, like x plus y to the second. This row of the triangle would be used for a binomial raised to the third, x plus y to the third, which is what we did over here, right? Somebody give me the answer to that problem we did on the previous slide again. Hannah, can you read that off for me? Wasn't it x cubed, the final answer? Okay. Now we went through the long drawn out process, a lot of work involved to get that. Well, let me show you before we keep going, and that's for x plus y to the third, exponent 3. Okay, the row of the triangle that we basically used was right here because that deals with exponent 3. Notice the coefficients. Notice the numbers on that row of the triangle. You see it? 1, 3, 3, 1. So these numbers on the row represent the coefficients of the expansion. All we have to do is pick the correct row. So whatever your exponent is, this is something that you should always keep in mind. Whatever the exponent is of the expansion outside the binomial, your answer, your expansion, should contain one term more than that exponent. How many terms do I have in my answer here? 4? Okay, what was the exponent? 3? It's always true, so you can kind of check yourself. When you're finished expanding, you should have an expression that has one more term than whatever the exponent was in your problem. So that kind of helps you know which row of the triangle to go to. Since this is exponent 3, I went to the row of the triangle that contains 4 numbers. Because this first row, remember, is for exponent 0. Exponent 0, exponent 1, 2, 3, and so forth. Okay, so we'll just keep on going. We would use, if we had exponent 4, we would pick this row of the triangle to use. If we had exponent 5, we would pick this row to use. So it's very important that you understand which row of the triangle you're going to need to do particular problems. And it's easy to remember. It's really going to be the row that contains one more number than whatever your exponent is. If this were exponent 9, x plus y to the 9th, then I'm going to go to the row of the triangle that has 10 numbers. I'll always have one more term in my expansion. Okay, so now that you know how to build it, let's use it. Let me show you how you can use it to make your life so much easier when it comes to expanding binomials of any power. Now, you don't have to write Pascal's triangle every single time. What I would do is make one big Pascal's triangle. You can look at your homework and see what the biggest exponent you're going to need is, and just make the triangle through that number, and then you can use that same triangle for all your problems. Now, just keep in mind, I am going to ask you to construct it on the quiz, so you need to know how we did that, the pattern. So let me walk you through an example of using the triangle to expand this trinomial a plus b to the 5th. First of all, notice the row of the triangle that I picked to use. I picked this row because it contains 6 numbers, and my final answer should have 6 terms. One more than the exponent. Okay? Here's how it works. I start by taking the first number from the row, from the triangle, that's 1, times, now, inside the parentheses, the actual binomial, the first term of the binomial, in this case it's a, I'm going to begin always by raising whatever that first term of the binomial is to this power. If this had been a plus b to the 12th, this would be a to the 12th. Okay? The second term in the binomial, the b, whatever it is, in this case it's b, it will always start off by being raised to the 0 power. All right? So it's very important that you get started off right, because from here a pattern starts. And if you start off with the wrong term and you apply the pattern, obviously everything else is going to be wrong. So number from the triangle, first one, that's 1. Look inside the parentheses and raise that term, whatever it is, to the whatever that power is. And then this second, in this case, variable inside the parentheses will always start off at the 0 power. Always. Okay? And now it's going to be pretty easy. It's a pattern. What's the next number in the triangle on that row? Casey? 5? Okay. Now the pattern works like this. The a, which is the first term inside the parentheses, it's going to go down by 1. The b, which is the other variable in the parentheses, it's going to go up by 1. And that's going to hold true from now until we finish. That's the pattern. Okay. Next number from the triangle, Noah, is 10. A goes down, B goes up. Heather, the next number from the triangle, 10. Heather, A would be to the what power? And B would be to the, very good. Whitney, next number from the triangle. A would be to the, B would be, good. And let me go over to Maggie, next number from the triangle. A goes to the, B to the, good. Now, this is not an answer that you should stop with. This is kind of like, hey, I'm new to this. This is kind of writing everything down so I can get to a simplified answer. What is b to the 0 power? 1. All right, so really my first term is going to be made up of 1 times a to the 5th times 1. And what is that? It's just a to the fifth. So writing what I have down here is great, but you really shouldn't stop there. This needs to be cleaned up. You need to just write that first term as a to the fifth. So I'm going to put my final answer in red. I intentionally put multiplication here because I wanted you to see that all of these, the first number from the triangle or the second number from the triangle, whatever, all of these are multiplied together to come up with a term. But we don't actually show multiplication for monomials, right? If we don't show any sign, it's implied that all of these are just being multiplied together. And I don't write exponent 1, but I wanted to so you could see the pattern. 0, 1, 2, and so forth. Okay, so with all that said, let me get to a final answer. That one's already good. And once again, Algebra 2 students probably shouldn't write exponent 1. And then when I get to this last term, 1 times b to the fifth. That's just b to the fifth. And can you imagine if we wrote a plus b down 5 times and started using FOIL and FOIL again and FOIL again, it would have taken forever, and Pascal's triangle got us there pretty fast. Okay, so there's an example of how to use the triangle to expand any binomial. Any questions so far? It's really, for today, that's the only type of problem you're going to be doing. Questions? All right, let's try another one. What makes this one a little different than the previous one? Do you see it? Good. Good recognition. Instead of saying x plus y, we have x plus a number. So that is going to factor into how we simplify, but the process is the same. Notice the row of the triangle I picked. Why do you think I picked that row? How many final terms should I have in my answer? How many? Okay, I should end up, since it's fourth degree, fourth power, I should end up with 5 terms in my expansion. So I picked the row of the triangle that has 5 numbers. Okay, let's walk through it. Row of the triangle, x will start off at the 4th power, 3 will start off at the 0 power. And in just a minute, I'm going to multiply all those together. Plus, next number from the triangle, x goes down, 3 goes up. Plus, next number from the triangle, x goes down, 3 goes up. Plus, next number from the triangle, x goes down, 3 goes up. And then finally, the last number on that row, x goes all the way down to 0, 3 goes up to the 4th. Now let me show you how it's a little bit different when there's a number involved in simplifying. Well, let's start with this. 1 times x to the 4th times 1. That's pretty easy. That's just x to the 4th. Be careful here. Common mistake is made. You got to remember PEMDAS. There's a certain order that we have to follow. We always do powers first. 3 to the 1st is 3. Now I'm going to multiply these actual numbers. 3 times 4 is 12. So this next term becomes 12x to the 3rd. I couldn't do that before because I had variables. I just had to show that they were being multiplied together. But with actual numbers, I can do the multiplication. Okay, be real careful here. Because remember, I'm doing powers first. I get some people that are going to be tempted to say 18 squared. What's wrong with that? 18 squared. What did I do that's terrible? Absolutely awful. PEMDAS, which says you do exponents first. 3 squared is 9. 9 times 6, 54. Okay, let's move on. 3 cubed. 3 cubed. 3 times 3 times 3. 27. 27 times 4. 108. So this is going to, I'll just bring it down here. 108 x. And what's my last term? 1 times 1 times 3 to the 4th. 3 to the 4th should be 81. So the blue, you can do it all the way across. The blue represents the expansion of that binomial to the 4th power. Any questions so far? You like Pascal's triangle? I think it's cool. Pretty nice. Show you a different method tomorrow. Questions? The only thing that really changes is the way the binomials are presented. I just wanted to give you maybe an example of each. The process really doesn't change. So this is a minus b to the 6th. Instructions are still to use the triangle to expand. I didn't show the triangle on this one, so let's just build it real fast. Tell me when to stop. Keep going? Is that good? Okay, that's kind of what I'm going to have you do on the test. I'm going to say, here's a binomial raised to a power, build Pascal's triangle through the necessary row. Well, in this case, you would stop here because that's all you need. All right, let's walk through it. How is it different when there's minus here? We didn't have that before. Well, I'm going to start off the same way I did before, just to show you another pattern that's going to develop. So, row from the triangle. Devin, A will be to the what power? Okay. And this time we're going to have negative b. And what is that power? 0. Okay. Next row of the triangle, 6. Colin, A will be to the, and negative b will be to the, good. All right, Sarah, next row of the triangle, or next number of from the triangle. We've done 1, 6, 15. A will be to the, and negative b to the, good. Let's see, Heather, next number from the triangle. A to the, and negative b to the, good. Whitney, next number. A to the, negative b to the, good. Kate, next number. A to the, negative b to the, and Hannah, last number. A to the, negative b to the, okay. Now, something cool is about to happen. When we have minus, the binomial is subtraction instead of addition. Well, first of all, what is this first term in the expansion? Casey, what's my first term after you simplify? A to the 6. I'll just put my final answer in red. Okay, well now let's move to the second term. I do powers first. This is negative, you can think of it as negative 1b if you want. But when I multiply all this together, since that's a negative b, what's the result? Negative 6a to the 5th b, okay? Or I'm going to say minus 6a to the 5th b. Okay? So I'll just mark these out so we don't look at them anymore. Okay, Colin, here I am. What happens to this after you square negative b, put it all together? Will you end up with a positive term or a negative term? Positive. Does everybody see that? So my next sign, all of this is going to become positive. When you square negative anything, it becomes positive. So my next sign should be plus 15a4b2. That's done. What do you think the next sign is going to be? Negative? Isn't that what will happen if you take a negative number and raise it to an odd power? It stays negative. So the next sign should be minus 20a cubed b cubed. Are you picking up on the pattern? So what should the next sign be? Plus 15a2 b4. What's the next sign? Minus 6ab5. Next sign. Plus b6. So this is another one of those always true statements. If your binomial contains subtraction, after the first term you will always have subtraction every single time. But then it should flip back and forth. It should alternate. So this pattern for subtraction in the binomial should always hold true. Make sense? Any questions? Okay, I think I got one more. Now let's take a look at a binomial that, as you can tell, one of my terms is actually a product. I'm multiplying 2 times a. We haven't faced anything like that in our previous examples, and you want to pay close attention to this because there are some common mistakes that people make when dealing with the expansion of binomials that look like this. Either the first or the last, or sometimes both of these terms represent products a number of times a variable. So watch carefully as I go through this example so you will know what to do. The row of the triangle that I'm going to pick should have 6 numbers on it, and it's going to be the row 1, 5, 10, 10, 5, 1. Okay, when I'm done, I should have 6 terms in my total expansion. So let's just walk through using the triangle. I take the first number from the row, 1. Now I'm going to multiply that times 2a. That's the first term in the binomial. And I always start by raising that term to whatever this power is outside of the parentheses. So 2a is going to be raised to the 5th. And the second term of the binomial, in this case b, will start off being raised to the 0. Okay, and now the pattern continues. The next number from the row, 5, times, this time 2a is going to be raised to the 4th power, and b is going to be raised to the 1st. So remember, the first term counts down by 1, the second term counts up by 1. This little separation here. Okay, the next number from the row is 10. 2a, this time is going to be raised to the 3rd. It's going down. And b goes up by 1, so it's going to be b squared. Next number, also 10. This time 2a is going to be raised to the 2nd power, and b is going to go up to the 3rd power. Alright, I'm going to come down here, continue. The next number from the row is 5 times, now 2a is going to go down to the 1st power, and b is going to go up to the 4th. Keep wanting to put parentheses around b, but really not needed. And then finally, the last number from the row is 1 times 2a has gone all the way down to the 0 power, and b has gone all the way up to 5, which is the exponent in our problem. Okay, now let's clean this up and watch carefully how we do this. we have a property, an exponent property that we talked about on Friday, and it's in your 4.1 notes, which basically says when you have a product like we have here being raised to a power, each of the factors of this product, meaning 2 and a, need to both individually be raised to this power. Okay, so that's why I think it's a good idea to do parentheses. A lot of people, and I'm afraid this is going to happen on Wednesday and it's going to happen on next week's test, a lot of people are going to say that when they take 2a and raise it to the 5th power, they get 2a. Well, obviously, if they get that, or 2a to the 5th, if they get this, they did not raise 2 to the 5th, and that's very important. So just to review that property, both of these factors, both of these numbers 2 and a need to be raised to the 5th power. And 2 to the 5th power, if you need your calculator, is 32. So 1 times 32a to the 5th times 1 is 32a to the 5th. So that's my first term. All right, let's make our way to the second term. Again, 2a, that's a product, 2 times a, being raised to the 4th, well, that's really simplified, that's 16a to the 4th. Okay, watch that carefully. And now, okay, I'm going to mark this out because I've changed the monomial 2a raised to the 4th into 16a to the 4th. And now I'm going to multiply. Okay, so just think about multiplying all of this together to come up with the second term. 5 times 16 is 80, and that's a to the 4th b. All right, same thing here. All right, here we are working on the third term. Well, 2a, the product 2a raised to the 3rd, is really 8a to the 3rd. I can't stress that enough. Don't forget, not only do you raise a to the 3rd, which most people remember, but you also raise 2 to the 3rd. And when you multiply all this together, 10 times 8 is 80. A to the 3rd, b to the 2nd. All right, and let's keep going. 2a, the product 2a raised to the 2nd is 4a squared. And now I can multiply 10 times 4 and get 40 a squared b cubed. All right. Now you can just, I'll just go ahead and keep doing my answer going this way so we can put it all on one line. 2a to the 1st, that's not too bad. Most people will get that right because that ends up still being 2a. And 5 times 2a times b to the 4th, that's 10. 5 times 2 is 10. A, b to the 4th. And then finally we end up with 1 times 1, anything to the 0 power is 1, times b to the 5th, and that is b to the 5th. So this ends up being my final answer. Just be very careful in cases like this where a product needs to be raised to a power. Each of these get raised to the power. Okay, so please don't forget that, and then make sure you follow the order of operations properly. Powers before multiplication, and hopefully that helps. So that is those are some examples of how to expand binomials by using Pascal's triangle. Let me know if I can help you.